Welcome to Warehouse Automation Matters. I'm your host, Mary Hart, and I'm here with Oscar Mendez, Head of AI and Data Science at Locus Robotics, to talk about AI in the warehouse. Welcome to the show, Oscar.
Hi, thank you for having me.
So to start us off, can you share your background and how it shaped your work leading AI and data science at Locus Robotics?
Yeah, of course. I am a researcher in robotics, computer vision, and AI at my core. I kind of always worked in this area. I spent my career kind of building AI on the edge. I did a PhD, then finished that in 2017. I won an award for that. I've won several awards in the field, including the best paper award at ICRA, which is something that I'm quite proud of. I'm also an associate professor at the UK Stop Computer Vision Research Centre in CVSSP. I'm a member of the British Machine Vision Association, and I'm the director of AI and data science at Locus Robotics. I've always gravitated towards robotics. I find that there's this really interesting way that robotics has of trimming a lot of the fat off of research problems. And it lets you really focus on this idea of like, does the robot do the thing? And in research land, the thing is whatever research or problem you're working on. But when it comes to industry, that becomes a slightly different problem. You're not asking just does the robot do the thing, but you're asking, does the thing make sense? Is there a way that we can take this capability that we're giving the robot and actually focus it into making it make business sense? And that kind of really shapes the way that I think about AI and the way I think about robotics at Locus. So one of the things that I really care about is answering the question, does the AI deliver on business value? And the other thing is how long before it does, right? So we're kind of trying to get this understanding of the difference between something that can be done, something that delivers business value, and something that can deliver that business value or that ROI to today. So when I'm leading my team within Locus, I am focusing on delivering that tangible value, making sure that we're building AI models that are not just kind of theoretical or benchmark driven, but that are actually kind of solving real problems in the warehouse.
In your conversations previously, you've mentioned agentic AI that applies AI holistically across the warehouse. What does that mean in real terms, and how is it different from what we're seeing in the broader AI conversation?
Yeah, so I mean, broadly speaking, this idea of holistic AI is something that takes you, from your input data all the way to what I would call like the business KPI that you're trying to solve. There's a lot of talk in the industry at the moment about AI in the warehouse and about all of these like specific skills that are going to be enabled by AI. It's a lot of impressive demos with robot picking up boxes and doing all of these atomic tasks like navigating around the warehouse. And it's answering the question, what can the robot do? What can the AI do? Like, does it do the thing? And again, it's not really the question that we care about. What we're interested in answering is this more holistic question of, is it actually delivering on those business KPIs? Like, what is the business problem that we're trying to solve? What are the metrics that underpin it? And are we optimizing for that directly? So to put it a different way, I like to think of the difference between the robot is being able to pick up a box and the robot picking up a box actually having a measurable impact in your throughput of your warehouse. So it's very different to have a robot that can do a thing and then integrating that robot into your warehouse in a way that increases your throughput. There's a long walk to walk between those two things. And I think that's the main difference between holistic AI and kind of like task-driven AI that we see from a lot of different demos. We at Locus try to ground our AI in real-world warehouse automation problems. We like to use our domain expertise and the fact we understand what those problems are to both decide where we're going to apply the AI and also to design the AI in a way that is kind of warehouse friendly or that kind of optimizes for those warehouse problems. And we generally have realized that a way of taking all of this way of thinking and kind of manifesting it in three key characteristics of our AI. So we talk about our AI being physical, and that means that it has real world agency and has a direct physical impact into the warehouse. We also have this understanding that our AI needs to be trustworthy. And what I mean by that is that it needs to be explainable because we need to be accountable to our customers. So when we talk about our AI and what decisions it's made, and when our customers need explanations, we need to be able to provide that. So it's trustworthy as a second characteristic. And then holistic AI is, again, this idea of adopting the warehouse as a whole in a way that is just not just focused on specific tasks. So our AI doesn't just move robots efficiently. It doesn't just pick up boxes. It reasons about the warehouse as a whole. It looks at how robots impact the entire operation, and it starts to orchestrate different elements in the warehouse, which, with some of our newer products, we're seeing that it also includes associates as well as robots. And basically, we're just kind of trying to ensure that we're delivering on that value and on that ROI from day one.
There's a lot of hype around robotics foundation models right now. What's your take on them, and how do we move from hype to delivering real business value today?
Yeah, so robotics foundation models are an incredibly exciting bit of research. As an academic myself and someone that kind of works in the field, they are this incredibly exciting idea that you can train an AI to effectively know how to control a robot. And we're seeing this being discussed more and more in the context of warehouse automation, but it's something that has been around for a few years in the field of robotics research. When it comes to applying them to the warehouse, I think they're too broad and too narrow. They're too broad in the sense that, or it forces you to think about embodiments that are not necessarily necessary for warehouse operations. It makes you think about solving problems that you don't necessarily have to solve. And it's too narrow in the sense that it's not thinking about the warehouse as a whole. Again, it's focused on this idea of I can have a foundation model that will help me operate my robot. And that's great, but it doesn't think about how that robot integrates into the warehouse. So it's too narrow in that sense. So in other words, robotics foundation models are incredibly exciting and very powerful, and we definitely engage with them at Locus, but they lack that kind of immediate business application. They're kind of promising to deliver value in the next 5 to 10 years, which is a laudable goal and something that we always keep an eye on at Locus. But I also think that they are falling prey to a common trope with AI research, where you kind of come in with your AI machinery, your big AI black box, and you throw away decades of research and you say, well, the black box does better. And that's not necessarily true anymore. There are important limitations to an AI black box. The first one is that it is very difficult to explain what happened, so it's not trustworthy. It's very difficult to train it, so you need a lot of data for that black box. And more what we're seeing is that the performance on them is not as good as when you crack it open and start to use your domain expertise to actually modify the way that it operates. The other thing is that this black box is so complex that it takes a lot of time to develop it. So when we do foundation models at Locus, what we try to do is focus on this kind of iterative value delivery, where each sort of step that we take on our AI journey delivers on that ROI, delivers that value for our customers, and it delivers it today as opposed to in the future. So we have a roadmap towards foundation models. We have a way that we're working to develop all of the AI tools and the concepts and the building blocks towards foundation models, but we're also making sure that we're delivering on that ROI today.
You've talked a little bit about physical AI. Can you explain what that looks like in the warehouse and why embodiment really matters for performance?
I think of physical AI as, at its core, an embodiment of an AI system. You take a neural network, you train it, you put it into a robot, and then that enables some new functionality on the robot. And that's an incredibly powerful idea because it means that you are enabling the power of AI, the AI's ability to do this broad understanding of a scenario and then employing that onto the warehouse. But I like to make a distinction between, AI on a bot and physical AI. So AI on a bot is just taking something off the shelf, putting it on a robot, and enabling new functionality. I don't think that's enough. I think physical AI is a much more intertwined idea of like baking the AI into the physical world that exists. So I kind of identify 4 different levels of this. So there's like purely virtual agents. You have virtual data in and virtual answers out. And then you have single agent systems that control one single robot. So maybe you have an AI that enables navigation and you can deploy that onto a single robot. And then you have multi-agent systems. So an AI that can control multiple agents, multiple instances of the same robot, for instance. And then you go into what I would call kind of true physical AI, which is this kind of heterogeneous orchestration, like an AI that can control robots with different embodiments, with different capabilities. But it can also start to get into this idea of using humans as part of the system and having that physical impact in the warehouse in a way that is much more broad. So at Locus, when we think about physical AI, we think it means more than just adding an embodiment. We think it means like meaningfully integrate the robot into your warehouse in a way that is holistic and that we make sure that it is relevant and impactful to the way that you operate in your warehouse. And again, delivering on those key KPIs.
So, how does physical AI help robots and systems navigate and adapt to dynamic environments, especially in high traffic or brownfield warehouse sites?
Yeah, so this is what I was talking about just now with the AI's ability to kind of identify trends in data. So it is something that is really interesting that is very difficult to do with traditional methods. With traditional methods, normally you need all the information about a problem. If you're going to turn around the blind corner, you need to know if there's an obstacle there for you to be able to deal with it. With AI, you start to get into a scenario where turning around that blind corner, you can start to make some assumptions like, oh, there's always an MHE there on a Tuesday at 4 in the afternoon. And the AI will start to pick up on those trends in the data in a way that is not necessarily obvious or easy to implement in traditional methods. So you can get away with a huge amount of uncertainty, which is key for particularly brownfield sites that haven't been designed for robots. So you can use your AI to detect unexpected obstacles, to plan for congestion, to start to understand what your load is going to be. We had examples of warehouses where, at a particular time of day, during a particular time of the year, the sun shines in a particular way that makes your sensors behave in an unpredictable way because the infrared from the sun is affecting their performance. And it's very difficult to put a rule-based system in place that will deal with that. But with AI, it becomes easy to identify those sorts of things because it does it in a slightly more data-driven way rather than having to be designed for corner cases that are very difficult for humans to kind of think about. Another example in which we use AI in the warehouse is doing something like an MHE detection. So it's a common issue with warehouses that there's people operating MHEs, that those MHEs can get in the way of robot operations. So our robots are able to detect those MHEs and plan accordingly so that they don't bump into them, so that they can navigate around them. And this is, again, that capability that's incredibly important for brownfield sites where the site is not designed for the robot and the robot needs to be able to adapt to that environment. And that adaptability, that ability to take noisy data and turn it into action is what AI is really powerful at. And the last example that I want to give you is something my team is working on, which is system-directed labor, which is, again, looking at the warehouse holistically and trying to use AI to optimize not just for like the position of bots, but also to start optimize for where people are going to go and where the load is in terms of the work that needs to happen in the warehouse. So we can start to plan for that, and all of that is AI driven, and it allows us to be really flexible with the way we allocate labor in the warehouse.
So, you talked a bit about being trustworthy. Why is explainability and being trustworthy such a priority for Locus, and what does it mean in practice for managers and operators?
Yeah, trust is a huge deal for us. We know that our robots can increase your throughput. We've done the analysis. We understand the kind of warehouse where we'll have an impact. So when we go to a customer, we want to be able to have them trust that assessment. So it's important for us that our customers feel like our robots are also being able to deliver on that ROI. We want our customers to trust our system. We want them to trust that it knows what it's doing, that there might be things that the robots can see or that the robots are aware of that are maybe not necessarily obvious to humans. And again, this idea that the AI can see trends in the data that are not necessarily obvious is something that sometimes people don't understand why it happens. So we want to make sure that when the AI makes decisions that we can explain them to our customers. And so this idea of being accountable to our customers, to be able to explain to you why something happened, and what the reasons the AI made a decision. And we sort of hope that eventually that accountability turns into trust in the system. So there's this idea of trustworthiness, something that is incredibly important to us. And then there's this concept of sort of explainability, which is a slightly more technical term. And explainability is something that is very active in the research community. And there are different levels of explainability. So at the base level, there's interpretable, something that like humans can look at and go like, okay, I can see how you made that decision. Intuitively, you're able to understand that. Then there is externally explainable. So normally with AI systems, there's a little bit of a black box element. You train the network and you kind of are just expecting that it'll do what it can do. And you have external tools that you can use to sort of poke the AI and try to get a response from it to understand why it makes certain decisions. So a classic one is you train a cat detector and then you show it a picture of a cat, you poke it with some tools and it'll give you like a heat map that just like shows what the network's looking at. And it's normally like the face of the cat, maybe the whiskers, sometimes the tail if it's in the image. That's kind of an externally explainable system. And then you've got self-explainable, which is an AI that can explain its own decisions. And this is kind of at the forefront of research. It's something that is incredibly exciting that we're doing a lot of work on. So we do all of the different types of AI at Locus. But definitely a lot of interpretable AI, a lot of externally explainable AI, and we're starting to push the boundary when it comes to self-explainable AI. So One of the things that I would love to see and that I want my team to work on and that we're actively pursuing is having our bots be able to offer kind of live commentary of what they're doing and why. I think that would be incredibly exciting. And then another thing, thinking a little bit more holistically that we're working on at the moment is being able to take, the entire state of a site as our Locus system sees it and be able to present that to our customers in kind of a human friendly way, in a way that that allows them to understand it in a kind of chatty way, and we're kind of leveraging LLMs to do that.
Can you talk a little bit more about how explainable AI can change decision making on the floor, especially for managers that want to balance performance and safety?
Yeah, so that's a really like important thing. I think if I'm able to give you a summary of the site that is presented in natural language, um, you would be able to react much faster, right? The training curve of a new manager or the ability to respond of an experienced manager suddenly gets shortened. Not only are you able to respond quicker, but the AI can give you information in a slightly more predictive way. So you can imagine that AI can analyze historic workload patterns and understand that, like, on this particular Tuesday, for some particular reason, there's a trend in the data that suggests that you're going to have a spike, or that you might have, it was a bank holiday Monday and you might have less associate on your floor. And so you might want to plan for that. And these kind of trends in the data that are sometimes hard for people to see are something that AI can understand and can offer to you in an explainable way so that you can trust that behavior. All of the visibility that an AI has, like for instance, an object detector that is explainable and they can understand how it works, can propagate that information and can sort of offer to you an insight into, well, your warehouse has a bit of a blockage on this aisle because there's some maintenance being done, or maybe it can help you plan that maintenance around loads or historic load times, or around some of the navigation that the bot's going to need to do, or even plan better routes for the bots based on maintenance that you need to do. So it's an incredibly powerful way of getting managers to, particularly when it comes to throughput and when it comes to safety, being able to respond to that more effectively.
You've described Locus AI as holistic. How does that broader orchestration layer connect everything from order input to labor and throughput?
I think we have AI that is holistic in the sense that it is directly looking at your KPIs, particularly throughput is something that we care a lot about. So we have AI at different levels. So we certainly have AI that works at this sort of low level on the bot, and I kind of keep talking back to the example of object detectors because I did my PhD in computer vision, so it's an example that is close to my heart. But we also have AI that works in navigation and that works in mapping, and it's all kind of like embodied locally on the bot. And then we move the remit or the scope or that AI higher and higher the level into this higher level orchestration, and we start to get into the realm of this more holistic AI. And it's not to say that there is one single large AI that controls everything, but that you've got all these building blocks that you can use in a slightly clever way to optimize the warehouse. So we see the warehouse as a whole when it comes to AI. We go from order input to orchestrating labor and bots and jointly kind of maximizing that throughput. And we do this in a number of different ways. But the key thing that we always try to keep in mind is that we want to directly optimize for business KPIs. We want our AI to directly impact those KPIs. And this, I think, is one of the key differences from some of our competitors, in that we focus on directly optimizing for the business objectives. And this is, again, one of the real strengths of AI. If you go back to kind of the AI revolution 10, 12 years ago when I was doing my PhD, there was this idea of the end-to-end training. You have input data, you put it through your AI, and you get your output. And if you're able to train that end to end, that means you tweak the parameters of your AI in a way that maximizes the performance in your output. And when we talk about holistic AI at its kind of core, that's what it means. It means that we can take that paradigm, that way of thinking where the whole system should be tunable to the problem that you're trying to solve, to the thing that you're trying to optimize, or to the KPI that you're trying to maximize. So our holistic AI means that we want to keep that capability, keep that real strength of AI. And like I said, we're doing it at a bunch of different levels in a bunch of different ways, but it kind of focuses on this idea of climbing what I call the AI ROI complexity ladder, of like atomic blocks that go towards.
You talked a bit about directing labor, so let's talk about system directed labor. How does Locus AI help integrate human associates into warehouse wide optimization?
One of the things that we've always focused at Locus is making people's lives easier, and I think SDL is not really a it's not a change from that. We are trying to do this in a really simple way. We just add an interaction at the end of every pick that an associate has with the robot. They just get something we call guidance, which is basically go to the next to aisle X, and that means that the associate, after executing a pick, knows exactly where they need to go. And so it really kind of simplifies people's lives. It makes it so they can just focus on what the robot is telling them to do, and not have to go on this search for robots. So it reduces the amount of walking that they need to do. It reduces the wear and tear on their bodies. And it's a key example of the kind of AI that we do at Locus. It's physical in the sense that it directly impacts warehouse operations, and it's physical at the broadest sense that it's orchestrating a heterogeneous set of agents. It's trustworthy because my team's working on this algorithm. We stand behind what it does. We understand it, and we can make sure that we deliver on those productivity increases. But we can also explain the way it works and what it does. And it's holistic in the sense that, it's this warehouse-wide optimization. And what it does is at its core really simple. It's moving us from a greedy optimization, so each agent does what's best for him or her, and it goes into what is called like a team-based sort of like a game theoretic approach where we're optimizing for the site as a whole. So not only do you have less stress, less walking, and easier training, but you're also doing that while ensuring that you have higher throughput in your site.
So, how does the scale of 5 billion picks at Locus and domain knowledge influence your AI development?
This is something that is hugely important to us. Everyone that works in AI and everyone that exists in the field knows that the data is hugely important. Data is king, is what we all say. Um, and we all know that you need a lot of it. You need depth of data. You need a huge amount of variety. You need a kind of breadth of data. But that data needs to be accessible, and it needs to be put into the context of the problem you're trying to solve. So you need a kind of quality of data. And at Locus, we have all of them. We have almost 30 gigs per second of data being produced out of almost 15,000 robots in the field. We have almost 9 gigs of mission data mission metadata being produced per hour. We have over 100,000 human to robot collaborators. We're spread over 350 cities. So that like breadth and depth of data gives a huge amount of insight into the way warehouses operate and into the kind of AI that we need to build. We have access to over 100 million SKUs with over 150 million miles of robot data covered by our robot navigation. And so that means that we understand the context of our data in a way that is really important. So we get that quality as well. To put that into context, 150 million miles is a few times more than most autonomous vehicle companies have. So we're trying to solve a less complex problem, the warehouse, than the open road. And we're doing it in a way that has more data. And all of this culminates in the number, it's all contained in the 5 billion unit numbers. So anyone that wants to do AI, anyone that wants to do foundation models, anyone that wants to build this kind of capability for the warehouse needs to have number on this scale. Otherwise, you're prone to overfitting and scalability issues. And you also need to know how to use that problem in a clever way. Simulation's not enough. You need to be able to deliver on that data.
So, can you walk us through what it looks like to climb the AI complexity ladder at Locus, what that is, and why that matters to customers now and not just in the future?
At its core, this is something that's based on the idea of domain expertise. It's something that I feel really passionate about, and I've been talking about this for a number of years now, since before I joined Locus. The idea that we can't have AI black boxes anymore. AI black boxes are not explainable or trustworthy. They're very difficult to make holistic because of technical issues with training. And more we're seeing regulatory constraints against those. If it's not explainable, you can't break it open. It's difficult to prove that it works. And more, what we're seeing is that they're simply not good enough. The performance that you get out of AI black boxes is just not up to scrap with what you get if you understand what's in it, and if you can construct the AI in a slightly more clever way. So to do that, you need what I call kind of atomic AI or atomic bits of neural machinery that perform one task and perform it really well. And very crucially, those atomic bits enable kind of the next step on the ladder. So you can combine this kind of atomic AI capability with the domain expertise, the fact that you understand what the problems that need solving are, and start to scaffold these things up. So you might combine you might combine little bits of neural machinery into something more complex, and you can use your expertise to figure out where they fit in the warehouse. To put this in different words, everyone wants to run before they walk. You have LLMs, generative AI, and all of these kind of foundation models that are very exciting. Everyone wants to do them before, but they don't have the expertise and don't have the problem that they need to solve with AI. So I think that there's so much ROI to be had in the atomic bits and the little bits of neural machinery. You can start with these things. You can develop expertise internally. You can deliver ROI early, value for your AI programs, and start to enable that climbing. So you can start with an object detector, which enables you to do semantic segmentation a bit easier. That enables you to use depth estimation using monocular cameras. That makes odometry easier, which makes mapping easier, which makes navigation easier. And suddenly you've got an AI that can navigate the warehouse effectively. And you've done it at every step by delivering value. And so when we do this at Locus, we can do this really effectively. We have the RAS model to deploy the AI as we're building all of these atomic bits. We can deliver that ROI to our customers quickly. We can iterate on the AI and we can keep improving it. And all of this is while keeping our eye on that goal of building a more complex system that is going to deliver on the really high end promises of AI. So you really kind of get the best of both worlds.
So, finally, what would you say to a warehouse leader that's overwhelmed by the jargon or unsure where to start?
Come talk to us. I think we know AI, not just me. There's a ton of us at Locus that know AI and deeply understand it. We know robotics, same thing. We have a lot of experts in this area. But I think what's most important about Locus, and one of the reasons I joined Locus back in the day, is that Locus understands warehouses. So Locus is a company that understands the domain that they're working in, understands the problem that warehouses face, and understands robotics and AI well enough to apply it to that problem. So we are domain experts in warehouse automation, and we have all of these amazing AI initiatives that are already in place to help solve the problems that we know exist in warehouses because we have the domain expertise. We have object detectors that help us do better navigation. We have work with LLMs. We're optimizing your labor. We have all the data to back all of these initiatives up, and we have the roadmap towards this, fancy AI that everyone wants to be involved in. But most importantly, what we can do is we can help you unlock the power of AI in your warehouse, and we can do so in a way that makes sure you're delivering that ROI today.
Thank you, Oscar, and thanks for being on the show today. I appreciate it. And thank you to our listeners. We're here to help you move what matters in your warehouse with unmatched flexibility and unlimited throughput.